ground rod gauge helps ensure proper grounding of electrical systems. To use it, firstly, locate the ground rod that you want to measure. Secondly, insert the pointed end of the gauge into the ground close to the ground rod. Thirdly, push the gauge into the ground until it touches the ground rod. Fourthly, read the measurement. The depth reading on the gauge indicates the distance from the surface to the ground rod. The ground rod gauge is used to verify the proper installation of ground rods, which are essential for redirecting stray electrical currents into the earth. Proper grounding helps ensure the safety of electrical systems and equipment by preventing electrical shocks and fires. The National Electrical Code, or NEC, recommends specific grounding depths for different types of structures. For residential buildings, the NEC recommends a grounding depth of 8 feet. For commercial buildings, the recommended depth is 10 feet. For industrial buildings, the recommended depth is 12 feet. Benefits of using a ground rod gauge include ensuring proper grounding, verifying that ground rods are installed to the recommended depth, and helping prevent electrical shocks by ensuring proper grounding. The ground rod gauge has a user-friendly design for quick and accurate measurements. You can order a ground rod gauge for free from the Galvan Industries website. By using this tool, you can help ensure the safety and reliability of your electrical systems. Grounding is a critical aspect of electrical safety and is primarily intended to limit the voltage on equipment enclosures and connected metal parts. In other words, grounding helps to minimize the risk of electrical shock during faults. The earth itself is used as a reference point. Grounding systems are designed to provide a low impedance path for fault currents to return to the source. This low impedance path facilitates the quick tripping of overcurrent protective devices like circuit breakers or fuses. Proper grounding helps to stabilize voltage during normal operation and limit overvoltages due to lightning, switching surges, or unintentional contact with higher voltage systems. According to the NEC, all grounding electrodes must be bonded together to form a grounding electrode system. This includes metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rods or ground rings. The NEC specifies minimum sizes for grounding electrode conductors and bonding jumpers based on the size of the service entrance conductors. Ground rods are typically made of copper or copper-clad steel. The NEC requires that ground rods be at least 8 feet in length and have a minimum diameter. They must be driven into the ground vertically or at an angle no more than 45 degrees from vertical, unless rock bottom is encountered. When rock bottom is encountered, the ground rod can be buried in a trench that is at least 30 inches deep. The location of ground rods should be accessible and free from physical damage. They should be located away from areas where they could be disturbed or damaged by vehicles, equipment, or construction activities. The resistance of the grounding system should be low enough to ensure that overcurrent protective devices will operate quickly and effectively in the event of a fault. The NEC requires that the resistance to ground should not exceed 25 ohms. If the resistance exceeds 25 ohms, an additional ground rod or other grounding electrode must be installed. The NEC specifies requirements for the type and size of grounding electrode conductors used to connect the grounding electrode system to the service equipment. Grounding electrode conductors must be protected from physical damage. They should be installed in conduit or otherwise protected where they are exposed to mechanical damage. Grounding electrode conductors must be securely connected to the grounding electrode and to the service equipment. Connections must be made using approved connectors or clamps. Bonding is the process of connecting together all metal parts that are likely to become energized during a fault. This includes metal conduits, metal enclosures, metal equipment frames, and metal piping systems. Bonding ensures that all metal parts are at the same electrical potential, which helps to minimize the risk of electrical shock. The NEC specifies minimum sizes for bonding jumpers based on the size of the circuit conductors. Bonding jumpers must be made of copper or other approved materials. They must be securely connected to the metal parts that they are bonding together. The NEC requires that all metal water piping systems be bonded to the grounding electrode system. This helps to prevent electrical shock hazards in bathrooms, kitchens, and other areas where people may come into contact with water. The NEC also requires that all metal gas piping systems be bonded to the grounding electrode system. This helps to prevent electrical shock hazards in areas where there is a risk of gas leaks. Equipment grounding conductors are used to connect the metal enclosures of electrical equipment to the grounding electrode system. This helps to ensure that the metal enclosures are at ground potential, which minimizes the risk of electrical shock. The NEC specifies minimum sizes for equipment grounding conductors based on the size of the circuit conductors. Equipment grounding conductors must be made of copper or other approved materials. They must be installed in the same raceway or cable as the circuit conductors. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit. If the current flowing out of the circuit differs from the current flowing back into the circuit by more than a few milliamperes, the GFCI will trip the circuit, cutting off the power. GFCIs are required in many areas of the home, including bathrooms, kitchens, and outdoor outlets. They are also required on construction sites and in other hazardous locations. Arc fault circuit interrupters, or RFCIs, are devices that are designed to protect against fires caused by electrical arcs. They work by monitoring the current flowing in a circuit. If the current exhibits characteristics of an electrical arc, the RFCI will trip the circuit, cutting off the power. RFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Surge protective devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. They work by diverting excess voltage to ground. SPD are often installed at the service entrance of a building to protect all of the electrical equipment in the building. Regular inspections of grounding systems are essential to ensure that they are functioning properly. Inspections should include a visual inspection of all grounding connections, as well as a measurement of the resistance to ground. Any problems that are found should be corrected immediately. Changes or modifications to the electrical system should be made in accordance with the NEC and other applicable codes and standards. All electrical work should be performed by qualified electricians who are familiar with the NEC and other applicable codes and standards. When working on or near electrical equipment, it is important to use appropriate personal protective equipment, or PPE. This includes rubber gloves, safety glasses, and other equipment that is designed to protect against electrical shock and other hazards. Lockout tag-out procedures should be followed whenever electrical equipment is being worked on. This helps to ensure that the equipment is energized and cannot be accidentally energized while work is being performed. Training on electrical safety is essential for all workers who may be exposed to electrical hazards. Training should include information on the hazards of electricity, safe work practices, and the use of PPE. The ground rod gauge is a simple but effective tool for verifying the proper installation of ground rods. It helps to ensure that ground rods are installed to the correct depth, which is essential for electrical safety. It is a valuable tool for electricians, inspectors, and anyone else who is involved in the installation or maintenance of electrical systems. The NEC is a comprehensive set of standards for electrical safety. It is updated every 3 years, and it is important to stay up to date on the latest requirements. Electrical safety is a serious matter. By following safe work practices and using appropriate PPE, workers can help to prevent electrical shocks and other hazards. Proper grounding is an essential element of electrical safety. By ensuring that grounding systems are properly installed and maintained, we can help to protect people from electrical shock and other hazards. Always consult a qualified electrician for any electrical work. Never attempt to perform electrical work unless you are properly trained and qualified. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Remember, the free ground rod gauge from Galvan Industries is a valuable tool for ensuring electrical safety.